Good morning, dear students. Welcome back again with a new session of Science 1, 9th Standard, lesson number 14, Carbon an important element, in which we have already discussed about crystalline form of the carbon. Today we are going to discuss about non-crystalline form or amorphous form of the carbon. The arrangement of carbon atom in this form is not regular. Coal, charcoal, coke are the three non-crystalline forms of carbon. First, we are going to deal about the coal. Coal is a fossil fuel. Fossil fuel found deep under the earth crust for because of the decomposition of the dead bodies of plants and the animals. It contains carbon, hydrogen, and oxygen. It also contains nitrogen, phosphorus, and sulfur. It occurs in a solid state. It is of four types. First type is peat. Depending upon the amount of the carbon, these names are being given here. First of all is peat. Formation of peat is the first step in the formation of coal. It contains high proportion of water and less than 60% of carbon, and therefore not much heat can be obtained from the peat. Second is lignite. Peat is transformed into lignite due to increased pressure and temperature inside the earth. It contains 60 to 70% of carbon. Lignite is the second step of the formation of coal. Bituminous coal. Bituminous coal was formed as a third step of formation of coal. It contains 70 to 90% of carbon. Then anthracite. Anthracite is known as the pure form of the coal. This coal is hard and contains about 95% of the carbon. Second form of the carbon is charcoal. Charcoal that is made from the animal is made up of from the bones and the horns, etc. On the other hand, charcoal is made from plant is formed by the combustion of wood in an insufficient supply of air. There is less amount of oxygen is supplied to it. The uses of coal. Coal is used in fuel. Coal is used as a fuel in factories and homes. Coal is also used to obtain coke, coal gas, and coal tar. Coal is used in thermal power plants for generation of electricity. Coke, the pure coal that remains when coal gas has been taken away from coal is called as coke. So the purest form of the carbon we call it as coke. Then uses of coke. Used as a domestic fuel, used as a reducing agent means helps to remove the oxygen from the compound. Then coke is used in the production of water gas, that is CO plus H2, carbon monoxide plus hydrogen, and producer gas CO plus H2 plus CO2 plus N2. CO implies carbon monoxide, CO2 is carbon dioxide, and hydrogen molecule and nitrogen molecule. Hydrocarbon, basic organic compounds. Along with the carbon, the element hydrogen is also included as the most organic compounds. The compounds formed only carbon and hydrogen are called as basic organic compounds. These are called as hydrocarbons. The electronic configuration of carbon is 2, 4. If 4 electrons are added to the second orbit of carbon, its octet becomes complete and its electron configuration becomes stable like that of the nearest inert gas neon 2, 8. Therefore, the valency of carbon is 4. However, this occurs by sharing of electron rather than give and take of electrons. In other words, a carbon atom can form 4 covalent bonds with other carbon atoms or atoms of different elements. When carbon atom shares 1 electron each with 4 hydrogen atoms and forms 4 C single bond H bonds, a methane CH4 is formed. The properties of covalent compounds. First property of covalent compounds. Covalent compounds have low melting point and boiling point. Here, the sharing in covalent implies sharing of electrons. So charge is not formed over it. Electrostatic force of attraction is not there, and therefore the bond formed is very weak as compared to ionic bond, and therefore they have low melting point and boiling point. Generally, they are insoluble in water and soluble in organic solvents. They are poor conductors of heat and electricity. That is, heat and electricity does not pass through the covalent compounds. Saturated and unsaturated. In simple one, saturated means those hydrocarbons which have single bond. Unsaturated means those hydrocarbons which have double or triple bond, or we can call it as multiple bond. A carbon atom exhibits a characteristic property. It can form a chain of carbon atoms by forming covalent bonds with other carbon atoms. The hydrocarbons having only single bonds between carbon atoms are called as saturated hydrocarbons. For example, ethane C2H6, which is CH3 single bond CH3. Propane CH3 single bond CH2 single bond CH3. Some hydrocarbons have multiple bond between the two carbon atoms. A multiple bond can be a double bond or a triple bond. Hydrocarbons having at least one multiple bond are called as unsaturated hydrocarbons. For example, ethene H2C double bond CH2, ethine HC double triple bond HCH, propene CH3 single bond CH double bond CH2, propyne CH3 single bond C triple bond CH, and so on. Does an electric charge form on an atom when a covalent bond is formed between them? No. Why is a single bond between two carbon atoms strong and stable? Here, compared to double and triple covalent bond, single bond is stronger. Charges are equally distributed. Now, solubility of carbon. In order to know the solubility of the carbon, here one short demonstration is being performed. Apparatus 3 conical flasks and stirrer, chemicals, water, kerosene, cooking oil, coal powder, etc. Procedure: take 3 conical flasks and take cooking oil, water, and kerosene respectively in each, and add half a spoonful of coal powder in each of the conical flasks. Stir with the help of stirrer. Absorb the mixture in 3 conical flasks. So, in water it is insoluble. So, in other organic solvents, it can be easily or it can dissolve to some extent. Now, reaction of carbon with oxygen, that try this is being eliminated this year. So we'll move ahead. Carbon dioxide. Molecular formula of carbon dioxide CO2. Molecular mass 44. Melting point minus 56.6 degrees Celsius. Occurrence. Carbon dioxide occurs in the air in the free state to the extent of about 0.03%. Exhaled air contains about 4% of carbon dioxide. CO2 is present as a salt in chalk and Shahabadi tiles, marbles, limestone. Carbon dioxide gas is given out in the combustion of wood and the fossil fuel coal. Now again here some part of this this is being eliminated from this for this year. So directly we'll move to chemical equation, which is useful for the preparation of formation of carbon dioxide. When calcium carbonate or limestone or marble reacts with hydrochloric acid to form calcium chloride, water, and carbon dioxide gases given out. So we are going to discuss about physical and the chemical properties of carbon dioxide. Observe the color and the gas formed in the above experiment. Smell the gas in the gas jar. So here table is there. In the table, as I said to you, you have to you can write it or you can remember it and understand it. So 2 questions are asked for the and for the chemical properties. Remaining other questions. Remove a lid of a gas jar and put some lime water in it. Place a burning candle in a gas jar. Drop a small amount of solution of some universal indicator in one gas jar filled with CO2 and shake it. Pour some water in a gas jar and shake it. Moisten blue and red litmus paper and drop them in a gas jar of CO2. Enter your observations in the above activities in the following table. First one, odor. Odor means here smell. It is odorless. There is no particular smell. So here you can write odorless. Color does not have any specific color and therefore it is also called as colorless. These are the physical properties. Now chemical properties of the carbon dioxide. Burning candle. If you put the burning candle inside the gas jar, the candle immediately gets extinguishes because carbon dioxide does not support combustion. Then, in the universal indicator is used, then it turns into yellow in color. Then, if lime water is passed through the carbon dioxide or carbon dioxide gas is allowed to pass through lime water, the lime water turns milky. When water reacts with carbon dioxide, carbonic acid, that is H2CO3, is formed. Then, when moist blue litmus paper and lead litmus paper is allowed to pass through carbon dioxide gas, now carbon dioxide gas being acidic in nature, here blue litmus paper turns red in color and red litmus paper remains as it is. Some more chemical properties of carbon dioxide which we are going to discuss. Sodium carbonate is formed when carbon dioxide is passed through aqueous solution of sodium hydroxide. Sodium carbonate is nothing but washing soda. Chemical equation of the reaction. Sodium hydroxide plus carbon dioxide forms sodium carbonate plus water. Sodium bicarbonate is formed by passing carbon dioxide through an aqueous solution of sodium carbonate. Sodium bicarbonate is nothing but called as baking soda. The chemical equation of the reaction is sodium carbonate reacts with water in the presence of carbon dioxide to form sodium bicarbonate, that is 2NaHCO3. Write down the chemical equation taking place between water and carbon dioxide in the above experiment. So this can be written as H2O plus CO2 gives H2CO3. H2CO3 is nothing but carbonic acid. Write down the equation of chemical reaction taking place on putting lime water into the gas jar of carbon dioxide. So lime water is nothing but you can call it as calcium. Write down the chemical reaction taking place on putting lime water in the gas jar. So lime water is nothing but calcium hydroxide. When carbon dioxide is passed through it, then calcium carbonate reacts with water, forms lime water, and when carbon dioxide is passed through it, then a precipitate is formed, a white color substance is formed which gets settled down at the bottom of it. So white color solution is formed, a PPT of white color is formed when lime water is passed through the or when carbon dioxide gas is passed through the lime water. Now uses of carbon dioxide. Now carbon dioxide is used to make aerated drinks like cold drinks like Thumbs Up, Coca-Cola. All these are of all these carbon dioxide gas is being used. Therefore, they are called as aerated drinks. Solid carbon dioxide is used in cold storage and also to keep milk and milk products and frozen substances cool during transportation. So freezer or fridge cannot be transported from one place to another. Instead, solid carbon dioxide is being used in order to keep the milk cold. It is also used for getting special effects of a mist on dramas and movies. Dramas and movies where cloud-like structure is formed, that is also done with the help of solid carbon dioxide. Carbon dioxide is obtained by chemical reaction or kept under pressure is used in fire extinguisher. Now, why it is used as a fire extinguisher? Carbon dioxide is heavier than air. It creates a gap between the fuel and the flame, and therefore the fire gets extinguished. And therefore, carbon dioxide obtained by a chemical reaction is kept under pressure and is used as a fire extinguisher. Liquefied carbon dioxide gas is used to remove caffeine from coffee. Then, liquid carbon dioxide is used as a solvent in modern eco-friendly and dry cleaning. Plant use carbon dioxide in air for photosynthesis. So, with for carbon plants cannot survive in the absence of carbon dioxide. Now, regular fire extinguisher. A fire extinguisher contains sodium bicarbonate, that is NaHCO3. There is also a dilute sulfuric acid gas in a glass capsule. The capsule breaks on pressing the knob. The sulfuric acid comes in contact with the sodium bicarbonate and two react chemically to release carbon dioxide which comes out. Carbon dioxide based fire extinguishers do not cause corrosion and are non-conductors of electricity. Therefore, they are used where electrical and electronic equipment catches fire. Carbon dioxide based fire extinguishers are used to extinguish small scale fire. It is beyond the capacity to extinguish a big fire. In modern fire extinguisher, liquid and solid carbon dioxide is filled under pressure. On reducing the pressure, it becomes gaseous and comes out forcefully through the horn-like hose pipe. Now, what is the chemical reaction and how does the carbon dioxide comes out? Now, sodium bicarbonate reacts with sulfuric acid to form sodium sulfate, water, and carbon dioxide gas is given out. Nowadays, many types of fire extinguishers are used. Collect more information about the way carbon dioxide is used to extinguish the fire. Now, we'll discuss about some properties of the hydrocarbon compound. Among them, first one is methane. Molecular formula CH4, molecular mass 16 of carbon and 4 of 4 hydrogen atoms. So 12 plus 4 is 16. Now, where does this methane occur? Methane occurs in a natural gas to the extent of 87%. Decomposition of organic matter in the absence of air, that is anaerobic, produces methane. Methane is present in biogas plant and therefore it is used in cooking also. Methane is also found in coal mines. Methane is found on the surface of the marshy places, which is why it is also called as marsh gas. तो दलदल के इलाके में मिलता है. On heating the mixture of hydrogen and carbon monoxide gases at 300 degrees Celsius in the presence of nickel as a catalyst, methane gas is formed. So there is one reaction through which we can obtain the methane gas. Fractional distillation of natural gases gives methane in the pure form. Now, what is fractional distillation? This is one of the experiments in which separate constituents or separate compounds from the petroleum is being eliminated because of the difference in the boiling point of the crude petroleum. So that method is called as fractional distillation. Now, physical properties of methane. Physical properties which we can see with our naked eyes. The melting point of methane is 1 minus 182.5 degrees Celsius. Boiling point of methane is minus 161.5 degrees Celsius. It is colorless gas. Density of liquid methane is less than that of the water. Methane gas is sparingly soluble in water, means hardly soluble in water, but it is highly soluble in organic solvents like gasoline, ether, and alcohol. Methane is the gaseous state at room temperature. Now, this was all about the physical properties which we can see with our naked eyes, but there are certain chemical properties which we should know it. Methane is highly inflammable, means it catches fires very fast. It burns by reacting with oxygen and gives a bluish flame. In the reaction, 213 kilocalorie per mole of heat is given out. Methane burns completely. Chemical reaction. Methane reacts with air, that is oxygen from the air, to form carbon dioxide, and water in the form of vapor is given out, plus heat is also given out. Then chlorination. Methane and chlorine reacts with each other at a temperature of 250 degrees Celsius to 400 degrees Celsius in the presence of UV rays or ultraviolet light to form mainly methyl chloride, chloromethane, and hydrogen chloride. This reaction is called as chlorination of methane. Here, chemical reaction CH4 plus Cl2 in the presence of ultraviolet light to form chloromethane or methyl chloride plus hydrogen chloride. Now, uses of methane. Methane is a form of natural gas used in industries such as fabric mills, paper mills, food processing industries, petrol purification. Being the smallest hydrocarbon, the proportion of carbon dioxide released in the combustion of methane is small, and therefore it is used as a domestic fuel. Methane is used for the production of organic compounds such as ethanol, methyl chloride, methylene dichloride, and acetylene. Methane gas was discovered by Italian scientist Alessandro Volta between 1776 and 1778 while he was studying the gases found in marshy land. Now we are going to discuss about the last part of this lesson, that is biogas plant.